Hey everyone, in this video I'm going to talk about how to find the second derivative implicitly. So in the previous video I showed you how to use implicit differentiation to take a derivative when something either wasn't a function or wasn't easily differentiable. So again, when we use implicit differentiation, we imagine that y is going to be some differentiable function of x. Okay, so in order to find the second derivative, just like we would in any other case, we have to first find the first derivative. So using implicit differentiation here, we can say that d dx of 2x cubed minus the derivative with respect to x of 3y squared is going to equal d dx of 8. And when we go ahead and simplify that, derivative of 2x cubed is simply going to be the power rule. That's just going to be 6x squared. And from that we have to subtract, and now here's where we have to use the chain rule. So the derivative of 3y squared is going to be 6y, but again, y was some function of x, so we have to use the chain rule to say, okay, it's going to be the derivative of the outside times the derivative of the inside. So we get 6y times the derivative of y with respect to x, whatever that function y was. And that's going to equal the derivative of 8, which is just 0. And just like before in the last video, we need to make sure that we get the dy dx on its own. So that means that we get a negative 6y dy dx is going to equal a negative 6x squared. And if we divide both sides, we're going to get dy dx. And that's going to equal a positive x squared over y. So this here would be the first derivative. Now it would be y prime. In order to find the second derivative, we need to simply take the derivative with respect to x again. So we're going to take the derivative with respect to x of x squared over y. And we know that because we're dividing x squared over y, this is going to be the quotient rule. So we use low d high minus high d low over low low. So we have y times the derivative with respect to x of x squared minus x squared times the derivative with respect to x of y. And the whole thing is over y squared. And so let's go ahead and simplify this now. So what we get is we get y times the derivative of x squared, which is going to be 2x, minus x squared times the derivative of y. Now the derivative of y would just be 1, but again, y was some differentiable function of x, so it would be 1 times dy dx. And then the whole function is over y squared. Okay, so let's just take this one step further here and simplify it a little bit. Really what we're going to get is 2xy over y squared minus x squared over y squared dy dx. Okay, and we can see that in this first term here we can cross out the y with one of those right there. So you just get 2x over y. Now we don't want to leave dy dx in our answer. So fortunately for us, we know what dy dx was equal to. We already found that dy dx was right over here, where it equaled x squared over y. So I'm going to go ahead and substitute that back in now. So this is going to be 2x over y minus x squared over y times, x squared over y squared rather, times this right here, x squared over y. So finally, to simplify it all out now, we have the second derivative, which we'll call y double prime, is equal to 2x over y minus x to the fourth over y cubed. So the process for finding the second derivative using implicit differentiation is to first, use implicit differentiation to find the first derivative, take the derivative of both sides, make sure you get dy dx by itself, solve for dy dx. And then to take the second derivative, you simply take the derivative again. Okay, but what's going to happen is at some point you're likely going to have this dy dx that you're then going to have to substitute for. So you're going to end up substituting the first derivative into some part of the second derivative in order to simplify. And then your final answer, in this case, is this right here, as long as, we should make a note, again, that y is not equal to 0, because then it would not be differentiable. I hope this video helps, and good luck.